Hey, this is OXDF, and today we're doing Advent of Code 2023, Day 14, Parabolic Reflector Dish. Um, Story, we're on a dish of some kind, blah, blah, blah. There's basically another grid, where we have flat stones that don't move. These that are the pound sign. We have empty space, which is the dots, and we have round stones, which are the zeros. And the idea is basically they're going to tilt the lever so that everything slides north. In this grid, north is up, south is down, west, east, etc. So you can see basically all the round stones are going to roll as far north as they can until they hit the edge or until they hit a square stone that doesn't move. So in this case, all of these round stones go up. All of these round stones go up. This round stone goes up, and then these two end up stuck at this one right here. So you can see that here, etc. And basically, then we have to calculate the total load, which is we're basically counting from the closer to the north edge you are, the higher your score. So it's the distance from the south edge, I guess is the way you could say this. So this is there's 10 rows, so this is a score. These rocks count for 10, these rocks count for 9, these for 8, etc. So we count the round rocks, multiply by their row number inverted, so high to low, and that's the score. That's the total load. So I've cheated a little bit in after reading this, I've been playing around a little bit with just like some functions to make sure we can manipulate things. But we'll give it a try here. Gen day 14. This is my script that will make me a stub and give me the input. We're also going to go ahead and create x.txt, so we have that as well. If you're interested in Gen day script, check out my repo. It's in the description here. Let's take a look at the input. It is not small. I don't know if it's square, but it's 100 rows, so probably not too different there. Head input.text, head -1 input.text, word count -c. Yeah, it's 100 by 100. So we've got to be somewhat efficient with our operations, but for one tilt, that'd be fine. The question is going to be, you can already see like what's the part 2 going to be. So, all right, let's think about this. So we're going to read lines into a grid, like we've been doing several times. To me, this tilt function is going to be so much easier working left to right than it is up and down. So what I want to do is make my north on the left side. And to do that, we need a rotation. And so we'll call like def rotate counterclockwise grid. I've really gotten out of the habit of type hinting. I wonder if I should get back into that. List of string. From typing import list, and we are going to return a list of strings. And so what we're going to do is we're going to take the grid, and how do we want to do that? Well, if we, let's see, we'll come down here and we'll say part1 equals actually, the other thing I'm going to do, I'll pass for a second. I'm going to want to demonstrate all these different operations as we figure them out. And so we're going to create a print grid function that takes a grid, which is a list of strings, and goes to none. And what are we going to do is we're going to just print. And I mean, this is not that complicated. We could just do this every time, but like, this will just be easier if we can do it this way. So now, if I come down here and say print, that's going to be a habit that's hard to break. Print grid, and we Python day 14 text. Let's see, what do we need to do here? We should do some stripping. We got too much. So where do we get to l.strip for l in l.strip, no need for that dot. And there we go, looks better. Let's see. So you can see we've printed the grid here. Does that look a lot like example.txt? Hopefully it does. Yeah, sweet. Okay, so we can print a grid. Nice and easy. Now let's come up here and rotate clockwise. So the trick I would definitely like to use is if we do zip star grid, that's our trick to work column-wise instead of row-wise. So effectively, that is going to flip it, take the top right and the bottom left corners and flip them across the diagonal like that. So I guess we can do that. Let's see. What if we just return that? I think that's not quite right. We're gonna have to turn this into a list, I think. Let's run it and see. Oops, let's see. Rotate counterclockwise grid. Let's see if we try to do that. And we get some errors. Print join grid, expected string found a tuple. So I think we're going to need to do tuple. Let's see. What if I just call print on that and see what I get? Make it a little simpler. A zip object. Okay, we don't want a zip object. So we want to turn this into a list. I think we need to do a little bit more though. Let's see what this looks like. Okay, yeah, so now we have a list of lists. We want a list of strings. So we want to do that. We're going to say we want to take each of these items in zip. We want to take this item and we want to apply the empty string.join. And so that sounds like a map operation. So we'll say map empty string.join is a function to the zip like that. Let's try that right here. And that looks a lot better. So now if we come back and make this print grid. Okay, so what have we effectively done here? So far, we have not, despite our rotate counterclockwise claim, we have not rotated counterclockwise. What have we done? Let's see if we can get this. You can see that we have, okay, so we have flipped. So this corner here and this corner here flipped. And so you can see where we started off with going down here, 0, 0, dot, 0, dot, 0. We have 0, 0, dot, 0, dot, 0 going across the top. Similarly, going this way, 0, a bunch of dots, pound, a bunch of dots, 0, a bunch of dots, pound, a bunch of dots. So we flipped it there. Now, to make this a counterclockwise rotation, what we need to do is just flip the rows. Is that right? No, we need to flip this up now, right? So what we're looking for, a counterclockwise rotation, we want to have this, we want to have pound, pound here. And right now we have pound, pound at the bottom. And likewise, we want to have, let's see, like this dot, dot. Oh, sorry, we should be looking up here. When we rotate this counterclockwise, the top right corner should be a dot. The bottom left corner should be a 0. So dot, 0. That, and then similarly, so the top row should go dot, pound, dot, star thing. Dot, pound, dot. So that's this right. This should be the top row. So we need to flip the row order. Hopefully this is making some sense. So once we have this map object, let's see, if we, in this list, we can do like this, -1. And now when we print this, we have, I think, a rotation to the counterclockwise. So this row right here becomes the column. So we will have dot, 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 pound, dot, dot, down to this rock, round rock here. The top row should be dot, pound, dot, o, dot, pound, dot, o. So we've now done a counterclockwise rotation. So I think we're happy with that. Now we have all these utility functions. I'm wondering if we should actually make this into a object. In fact, I'm going to do that. Let's go class grid def underscore init. We're going to take in, what do we produce here? G, which is going to be a list of strings. We're going to return none. Self.grid equals G. We should just call it self.g for simplicity. And that looks good. Now we can do this. We take self like that. And instead of returning it, maybe we are going to, in fact, we don't need to even take the grid because we already have the grid. We will say self.g equals like that. I'm going to call it self.grid so I can not have to rename all these things. Like that. And then this one, print is going to just take self. We're going to print self.grid. That looks pretty good. So now we're going to say grid equals that. We're going to need that. There we go. And now we can call grid.print_grid. Okay, get out of here. We're going to say slightly differently. We're going to say grid.rotate counterclockwise, and then we can do grid.print_grid. In fact, we can do grid.print_grid ahead as well. Now we can go full screen, run this. Whoop, we got an error. It was not a grid. Oh, because this is, let's see, self.grid. Sweet. Okay, let's see if that worked. Probably gonna want to put a space in there. You can see the difference, and let's see. So now we have this row right here should be the column, so we should have 0 up to that looks nice. This, yep. So we've done it. All right, 10 minutes in, and we have officially rotated the grid. We've not even now solved anything. So now we want a tilt function, right? And so let's start to play with what a tilt function looks like. If let's see, def tilt north south turns none. Okay, so what are we going to do? We want to work off of a row. And so it might be easier, actually, if we think, let's pass here for a second. Let's come down here and get, we've now rotated our grid. If we say row equals grid.grid sub 0, let's just get that first row. Going to comment you out, comment you out, comment you out. I don't need you. Okay, so now we're gonna rotate and we'll get this first row. If we print row here, we have the first row. Great. Which would be this right here because we've rotated. Yep. Okay. Now we want to tilt it. So we want everything to go to the left as far as we can. So what we're going to do is we are going to split this. So row.split on this. And now we should have a couple, we've got 3 things. Now what we're going to do is because we split on those, we want to sort those. So now we can sort sorted S for S in row.split. See if that works. It's a generator. Let's make that a list. Sweet. Okay, so now they went the wrong way though. So let's see. We want to sort reverse equals true. And that worked. And now we need to join them back together. So we could do our map thing we did up there. Or we could just do dot join. I think this will work. Let's get rid of that and that. Put that there. That's a not happy expected string found list. Let's see. Maybe we need to actually give it a list. That sounds like that's gonna make it happy. Okay, so we have, let's go back here and take this out and go back to where we were. Known good, right? Okay, so we've got these lists. We've got this sorted object here, which is a list. Oh, maybe we need to do this in here. So we need to do dot join there. Oh, and we're not actually joining with empty string. That's the problem. Also, we're going to join with that. So now, no, that's no good. That's where we're going to join with an empty string. Getting ahead of myself. There we go. Now we have our sorted 3 things, right? And those we want to take and join with that. Let's see. Is that going to work? Sweet. Let's see. If we do print row, we should see if this sorts. And it does. We can change this to row 1. And nothing interesting in row 1. I'm just guessing at rows here to try to check our work. That seems to have worked correctly. So I think we've got a good one working there. What we don't want to do now is, let's see. So now we want to take, let's call grid.print_grid. And then we want to make this not just, we're going to loop over all the rows. And we're going to do this in one line. This is going to look ugly, but it's going to be good. So now we have this whole thing. Get rid of the print for a second. And this is going to be for row in grid.print_grid. grid. We're going to move this up into the function in just a second, but once we're just playing with it to make it work, get it working. Print new line dot join, like that. Let's see if that works. So if that's the case, we have, I should have put a space in here again, but effectively we can see everything is rolled to the left, and that looks pretty good. So if that's the case, let's take this. We don't need this part right here. In fact, this part right here is part of the gritty stuff, so we don't need that. This is what we need right here. Let's go up here and call tilt north. I'm going to say self.grid equals that. What happens if I run black on this? Okay, that's a little better. So for each row, we're going to take it, we're going to split it, sort it, and join it back together and get it back into our grid. And so now we can come down here and say grid.tilt north and then print grid. Don't need that print grid. Let's put that print grid back and that print back. Okay, so now if we run this, we've got, in fact, let's get rid of this print grid and come back and bring out this one. So now we can see, we can go from rotated to tilted. We definitely want a, that there. Okay, so we've now taken this, the rocks seem to have all slid down. This is working great. Okay, now we just need to score it. And we're done with part one. This is the hard one. So let's see. What did they call it? We'll try to be accurate here. What am I trying to calculate? The total load. So int. And so what do we need to do? We need to, for each row, because we can just look at this row wise, and they would do it column. We'll start here, and this will be the number of things here minus the index. So that's that. So we're gonna say for row in grid self.grid, and then we'll say for we'll want to enumerate that r comma row and enumerate self.grid for, yeah, I think that's fine. Okay. We can get len self.grid 0. So let's just get that. We don't have to do that over and over again. Num len row equals that. So now for each item, and actually we don't care about this R number here. Sorry, it's going over my head here. So we're going to go over each row. In each row, for I, comma, ch in row, enumerate row, we do care about that. Then we are going to total equals 0 if ch equals, I believe these are zeros. Let's just copy this so we can be sure. ch equals that. Then we're going to do total plus equals len row minus, so in row 0 we subtract none, etc. And then we could make this into a really funky one-liner, but we can, for a second, let's return total and let's see how we're doing. So now, in theory, grid dot total load. In theory, we might have an answer. 136. That is definitely what the answer was. We should check, make sure, but I feel very confident that's what it was. Sweet. Let's on input and see if we get an answer that we like. Boom. Before I read part 2, I do want to play with real quick, and you can skip. I always put the little timestamps in here, so you can skip this section if you think this is boring. But I think we can do this in one go. So we're going to say sum. Maybe we should start on the inside. For I, comma, ch and enumerate row. And then we need to do for row in self.grid. We can just say I for now, just to make sure that works. Okay, that works. Some that. Okay, so now we've made this. Oops, get rid of this. There we go. That is the sum, and we just need to fix what this is. Oh, and we need to do if ch equal to. I still can't tell if that's a 0 or no. We'll just copy that, and this will be len row minus I. Total equals, and we can comment all of that out. Not that one though. Not as readable. Did I get the same answer? I really should get rid of these prints. But not, I should not get rid of the actual, so we need to get rid of that, and that. Okay. I think that's the same answer. 136, yeah. So we can do this either way. I might even comment this out and just do that. Sweet. Okay. I'm going to leave this in here commented so you can sort of see the pretty and the not. Let's black that and make sure. So make it a little bit. I don't know if that's more readable or not. Takes just as many lines all of a sudden. It went from one liner to the same number of lines. Okay. Reading part 2. Back with you in a moment. All right, so we're gonna do this a little bit differently, and I might be moving to this in the future. I just floundered with this for 30 minutes, and there was a lot of me staring at the screen going, what's going on? And I don't think that's a very interesting video. So I've solved it. I've reset my code back to where I was, and we're gonna kind of walk through it. I think it'll make a better video. I can sort of explain what I'm thinking, as well as the pitfalls I fell into. So part 2. A cycle is going to tilt the platform 4 times, north, west, south, east. So we should think about what a cycle is. As if we are keeping our north to the left side, if we tilt north and then turn, the next way we want to tilt is west, which will be down. So if we tilt north and then rotate clockwise, then tilt north, I still say tilt left, rotate clockwise, tilt left, rotate clockwise, tilt left. So effectively, if we tilt rotate 4 times, we'll end up back with the orientation the same, where north is left, which is what we want for scoring, as well as we'll have done each of the things. So that's what we're going to do for a cycle. But the cycle tilts 4 ways, and they show us some examples, and then they want us to do a ton of cycles. Let's see, that's thousands, that's millions. There's a billion cycles. Clearly, we're not going to be able to calculate a billion cycles. It'll take forever. But we're gonna have to look for a little loop where after some point of time it'll start seeing states it's seen before, and once it's in a state it's seen before, it's going to see that state again, and we can work with that. So, like I said, I've already solved this, but we're going to go back and I've kind of reset us to scratch here, and we're gonna do it. First thing I'm going to do, and it took me some troubleshooting to get through this. The first thing I'm going to do. This right here really cost me. This probably cost me 20 minutes, which is again why I'm cutting that out of the video, because it's not interesting. This is not grid. This should be self.grid. But because I call it grid.grid and Python's being nice to me, it picked up this one. And so what I actually am going to do is, in fact, you can see I believe this was all one line before. I'm going to create, we're going to save grid lines, and we're going to do this. And then for part 2, we're going to come down here and say grid2 equals grid on grid lines. And we will, get ourselves grid dot rotate. You know what I should do? Just because rotating counterclockwise is not an action we're taking, it's actually like part of getting ourselves oriented. We should just call self dot rotate counterclockwise right there in the init. That way we don't have to mess it. It doesn't look like an action we're taking. We should make sure that still works. I believe that was 105.623. Not fall in a rabbit hole. Yeah, okay. So that's better. So now I've got 2 different grids. But the problem was before, whenever I was trying to do a tilt, I was tilting the first grid that I had called grid down here, which makes no sense, but so it's screwing me up. So this really needs to be solved. That's important. Otherwise, this all is fine. So what are we going to do? We're going to make a function called tilt cycle. We'll come here and we'll do def tilt cycle, self goes to none. And for tilt cycle, we're just gonna do for blank in range 4. So we're gonna do it 4 times. We're going to do self dot tilt. I really should change tilt north to tilt left, but we're gonna stick with it for now. Rotate clockwise. Now, we haven't written rotate clockwise, but we're gonna take a lazy way on this. We could, I believe there's a similar thing where we could flip it and then change the orders again, just like we did up here. But since we're gonna find a cycle, clockwise self goes to none. I'm gonna take a very lazy approach to this. Self dot, and because this video is getting too long already, rotate counterclockwise 4 underscore in range 3. Because rotating counterclockwise is the same 3 times, is the same as rotating clockwise once. So we've done it. We've now got a tilt cycle. In theory, we should go come down here and let's say grid 2 dot tilt cycle, grid 2 dot print grid. We run this on our example, Python day14 example.txt. We should be able to compare this to the grid that they give us. Now, we're north, our north is left, their north is up, so it'll be slightly different, but so we should expect to see after one cycle, this will be our left row. That looks good. This will be our top, so it'll be rock, 1 row. That looks good. Our right, their bottom should go. Yeah, so we're matching. We are doing it successfully. And I got this pretty quickly last time too. It's when I was doing it down here, but then as soon as first of all, oh man, the grid thing, man, that bites me. Okay, anyway, I'm stop complaining. Now what we want to do is we're going to take that and we say, okay, we want to tilt cycle, like to do multiple cycles, right? So I'm going to make another function, def tilt cycles self I, and we go to none, and we'll do, so this is the one where in theory, we could just like, okay, we'll do it, 4 over I times. We can't do that, right? So what we're going to do is we're going to say states equals self.grid. And we're going to say that. Oh, let's see. There's another optimization we should do before this. And I've already started it down here. And this was not, I actually left this one in. We're going to use tuples instead of strings, instead of lists. We can come up here and we can make this a tuple. Here, when we do self.grid equals list map, we're just going to do tuple. That should be fine. Where else do we use lists? Here. So this will be tuple. And the reason we're going to use tuples is they're immutable, so that's going to be nice. It's going to help us make sure we're not changing where we don't want to change. But it's also going to allow us to save states more easily. Do I need to save? I think this is fine. Do we need to make, that's a list, but then I'm joining it into a string, so that's fine. Okay, so we have tuple there. I think that's all we need to change that into tuples. So now we can do save states is equal to a list of self.grid. And now what we're going to do is we're going to say count equals 0 while count less than I, because if we get to I, we're done, right? We will self.tilt cycle. We'll do our tilt. We'll count plus equals 1. We've now tilted once. If self.grid in states, so if we've seen this before, we're going to break our loop. Otherwise, we're going to states.append self.grid. Now we've saved that again. Okay, so now at this point, we'll get to the point we'll break. Count will be the first time we've repeated a state. So we can say if count, or it'll be I guess. So we'll say if count equals I, return. We're done. We don't need to do anything else. If count is not equal to I, we need to fast forward the number of things. So we can say first scene equals count. Oh wait, sorry. Let's First scene equals states.index of self.grid. So tell me the index of this grid in my states. Now we know our cycle time is going to be equal to the total count minus first scene. And we'll step through this in a second so we can see what that looks like. In fact, let's step through it right now. So we're going to do this. We'll hit F5 to run with our example input. And we did not, because we haven't called this yet. Great. So we are going to call, we're going to create our grid. We're going to grid 2.tilt cycles. Let's just do a high number. We're not going to get near that far, especially on the toy input. So if F5 here, we hit our break. Let's step, we can look. So first scene is 3. So if we do states of 3, we get that. If we do self.grid, we can see those are the same. These tuple of strings, they match. So that tells me, we can play with this. Like that tells me, what did I say? Count equals 10, first scene equals 3. So in theory, every 7 steps now, we're gonna end up back in the same spot. So if we do self.tilt cycle, it's 1, 2, 3. And if we look now, we can just compare real quick. States 3, where's my self.grid? We are not the same anymore. You can see these are different. We've tilted 3 times, 4, 5, 6, 7. Now if we do self.grid and states 3, we can see we're back in that same state and it worked. So every 7 cycles, it's going to be the same. So what we need to do, if we want to skip ahead, we can do self.grid is equal to, and now we need to calculate that. So we're going to say states. Which state do we need? Well, we want to go to I, so we'll do I, but the first scene is kind of screwing us up, right? So in this case, where we first see it at 3, and then it cycles of 7 after that. So we are going to be, let's pretend we're at state, remember, first scene is 3, cycle is 7. If we're at state 31, well, we know if we know that is actually going to be the same as state 3, right? Say 3, 10, 17, 24, 31. Those are all things of 7. The way we can get to that is we'll say I minus first scene. We want to get rid of that so that we're kind of working off of our same state. Then we can take this mod cycle like that. And so now that'll reset this as tells us how many we are there, but then we need to add back in first scene to get our index back. And that should be states, should be our grid. And so in theory here, now what we've just done is we've said, hey, do this for a while, but then let's just calculate, okay, we know, let's just jump forward to this point in the grid and stop. We don't have to do all these calculations over and over again. So let's stop this. Let's come down here. Let's get the actual number here. Moved it off screen. Let's see, we need that. We're looking for 64 for our input. So we'll run this here and we will go back to the terminal. Let's exit the Python one. Run this with example. Oh, we got a problem. List this place. List. Let's F5 it. Oh, I don't have a breakpoint. Oh, I do have a breakpoint. Great. Okay. So I minus first scene. Great. Cycle 3. Oh, that's nice. Plus first. Oh, I know. Why am I just making a list of it? That's just floppy. Okay, let's stop. Terminal. Exit. Yes, I know you exited. Oh, so now what do we need to here? We're just going to do part 2 equals grid 2 dot total load. We get 64, and we get 98,029, which is the correct answer. This is a tough one. I may start moving to doing even more. I've been doing kind of a hybrid of like read the problem, think about it a little bit, maybe toy around a little bit with some ideas, but then come and like try to solve so you can sort of see my thought process. But as these start to get harder, I'm going to do more. I think I'm going to do more solving ahead and explaining after, because I just think it's a better video, and this video is already quite long. So let me know in the comments if you have thoughts about that. If you'd rather just see me flounder for half an hour and stare at the screen and go like, okay, let's do some debugging, or if you think it's better for me to try to tighten it up a little bit. So thanks for hanging out with me today. I will talk to you tomorrow.